Hello, everybody, and welcome to the number one Generative AI Meetup Podcast in the world, as Mark would like to say it. Today, we have a conversation with the head of TypeScript and partnerships at LlamaIndex, a really cool framework that allows you to give your LLM custom data to make it respond with information that is more recent, relevant, and personalized for your specific use case. We have Ding, is that how I pronounce your name?
Yes.
From LlamaIndex. And remind me, were you one of the co-founders with Jerry?
No. I came on after they raised money.
Okay. And I read from your LinkedIn, you're like a TypeScript
Yes,
king. I love TypeScript. It's fantastic. That's what I've worked with for most of my career.
So the very first time I met Jerry, it was at a hackathon. And yeah, full circle. First circle. No, I mean, I would not have had this job if it weren't for hackathons. I met Jerry at a hackathon, and I said, "Hey, you should build this in JavaScript." And he's like, "I'm not so sure." Partly because he's like, I don't know if I want to be seen as competitive with LangChain. And I'm like, "You're going to be seen as competitive with LangChain, Jerry. Don't worry about that part." But yeah, so after that, like we start talking, and then I built out the first version of the TypeScript library. And since I was the only one working on it, I was just like, okay, I'm going to be the head. So
nice. So when was that? You said late 2022, around when ChatGPT started getting popular.
Well, so Jerry started LlamaIndex in November of 2022. It was called GPT Index, basically combining GPT with data, so data indexing GPT. I joined, like I said, about 7 months ago. So, but the hackathon we were at, I think, was in February. It was at the emergency ChatGPT hackathon.
Emergency ChatGPT hackathon?
Yes,
wow.
because they put out the ChatGPT API, the ChatGPT API, not the GPT-3 API, but the ChatGPT API, like Monday, and a couple folks in SF were like, let's have a hackathon. They literally put this thing together in like 5 days. And they got like 5 different sponsors also. So
wow.
Yeah.
That's impressive. So you mentioned that it's a kind of a competitor to LangChain. Like,
yes.
How is LlamaIndex different from LangChain?
Yeah, so basically when they both started in November of 2022. They actually, fun fact, so Jerry and Harrison were both at Robust at this hackathon. And I would say that the differentiation when they first started was that LangChain was more focused on chat and agents, and LlamaIndex was more focused on data, vector databases, that sort of thing. And that's, for us, even up until today, like the main focus is really about how do we deal with the data that you want to use with your LLMs, right? Early days, like, it was just open source. Like, if you went to the LangChain docs, it would be like, hey, if you want to use a vector database, here's how you do it with LlamaIndex and LangChain together. And then, if you, on the LlamaIndex side, it was like, hey, if you want to build a chatbot, here's how you combine what LlamaIndex has with LangChain's chatbot modules. And then, of course, you have a couple companies called Sequoia and Greylock, and, then there starts to be convergence. But I think for us, it's always about data, right? And some of the early talks that Jerry gave, I remember one, it was just like, he just keeps on talking about data structures. It's like, you got this data structure you can use, you can have this data structure you can use, you can have this data structure you can use. And then the funny thing was, like, after talking about this for about 5 minutes, he's like, is this too easy for you guys? Like, is this like stuff that like you guys all know? I'm like, Jerry, you've lost everybody. He's better at the public speaking, a lot better now. So, but yeah, that was his initial focus, and that continues to be the focus of the company.
Okay. Is there a recommended data structure that you push for? Because we're really excited about vector databases to create embeddings that represent the context and nature of the text.
So yeah, I mean, like, I would say the vast majority of people ended up using the vector store index, right, with the vector databases. That was the one that won out. I mean, the summary index is still used in certain places. The tree index is not really used that much anymore. But what ended up happening is you start with the vector store index, but then you build strategies on top of it. So we have a number of different, what we call production RAG strategies that you can build on top of just saying, hey, I'm going to retrieve the top 5 nodes from the vector DB. One thing you can do is you can retrieve 20 nodes, and then you can re-rank them. So you use an algorithm to re-rank them, and then say, okay, so I'm only going to send 5 of these to the LLM, but I'm going to retrieve 20 from the vector DB. I'm going to use a different algorithm, or a different model, actually, to re-rank them, find the best 5, and then send those 5 to the LM. So that's one of the sort of production RAG strategies that we have.
I guess that kind of takes care of the smaller context windows for LLMs and being able to get the most relevant data.
Yeah, so context windows management was one of the really big reasons for LlamaIndex to start, right? It's gotten a little bit less urgent as the models have larger context windows, but you still will hit into that, and also you'll pay for it, right? The more you send to the LM, the more you pay for it. But probably the bigger problem is the sort of like garbage in, garbage out problem, right? Mm-hmm. If you start sending the LM irrelevant data, they're not going to give you a very good response. It's just like a human being. If I dropped the entire U.S. tax code on its desk, and I'm like, hey, Shashank, I have a tax question for you, you're not going to give me a really good answer, right? So, like, really finding the most relevant pieces of information and getting that to the LM is very, very important.
That's a good point. So you mentioned before that there's all these different types of indices, or indexes, like a summary or a tree index. Like, if I'm trying to determine what's right for my project, like, what would be kind of like the use cases when I'd want to use those particular types of indexes?
I would say, like, once again, I would say the tree one is a very specialized thing that you probably don't want to worry about now. Vector store index is where 90% of the work is being done. The summary index is useful for summaries. It used to be called the list index. Now it's called the summary index because it is actually useful for summarization. So those are the two that I would really think about. But once again, on top of that, additional strategies to get you better performance.
Okay. So that's like the filtering techniques that you mentioned.
There's so many different techniques. Re-ranking is one of those. And then another one is we have this whole class of strategies that we call small to big, or another way to say it is like the embed small, retrieve big strategy, ESRB. The idea here being, like, basically one of the things you need to make sure is that your chunks are semantically coherent, right? Like, what does an embedding model do? I mean, it takes some text, transforms it into a bunch of floating point numbers. What do those floating point numbers represent? I have no idea. Neither do you. Neither do the people who actually built these embedding models, okay? But you can kind of guess that there's a few different things that go in there, one of which is meaning, semantic meaning, one of which is actually keywords. You think, oh, why, like, we have keyword search already, why does this thing do any keyword stuff? Well, because if it didn't do anything with keywords, it would give you really bad results, right? So keywords is part of it. Semantic meaning is part of it. And if your chunks are more semantically coherent, right? If they have one strong meaning, then you're going to get a vector that's more unique, right? So if you have these big chunks, which is where we start people at, the nice thing is that it's kind of likely, just almost by chance, that you're going to get the data you need when you do the retrieval. But the problem with that, with the big chunks, is that they're not very semantically coherent, right? And so what happens is these vectors start looking a lot like each other. So now you can go smaller and smaller and smaller. Like, what's the smallest place where you can be semantically coherent? It's probably at the sentence level. Subject, verb, object, right? At that sentence level, the problem becomes that there may be other things that you want to send to the LLM right around that sentence. Very, very simple example. You're like, Shashank, he's hosting a podcast. He also enjoys playing basketball. Okay. If I ask a question about Shashank, once again, there is going to be some keyword search in there, right? So it's very likely to pull that first sentence, right? But if I said, hey, what are his hobbies? That's not in that first sentence. You need the sentences around it to give you the context. So you can embed smaller, but you want to retrieve around it. So we have a number of different strategies around that. This one is called the sentence window strategy. But yeah, it's something that we see people use time and time again in production applications.
I think I saw in one of your demos you get the next and previous sentence.
Exactly.
Retrieving.
Exactly. And then it's configurable, so you can have more sentences also.
So you also mentioned keywords is kind of like used in like the traditional search field.
Yeah.
How would a traditional search compare to a vector store? If you were just to search for keywords and return, like a similar sentence with some window before and after.
Yeah. So first thing that I think people should remember is that keyword search is very good. Google equipment, right? Google is a very, very, very successful company, right? So keyword search is very, very good. Now, where does semantic meaning come into play? It's where it's magical is when you have none of the words matching, but the meaning matches, right? So semantic search is that sort of like when it works, it's like, hey, how do you even know that this was the right thing to find? Oh, because it understands the text, right? It actually understands the meaning. People have tried, this is not a new problem. People have tried extending keyword search by using basically banks of synonyms, right? If you use Bing, you'll find that they have some kind of ML automated synonym generator that's very, very aggressive. So sometimes, because now they highlight where the search term was found, you'll see the highlight and it's like it has nothing to do with your search term. So people have been trying to do that. Now with semantic search, it's done automatically for you by the model, right? The model is understanding the content and saying, okay, well, this is similar to something else. So I think these two things are complementary.
Yeah, that reminds me of how Shopify is trying to improve the search experience across all their stores.
Yep.
So they're enabling users to search for concepts in like an abstract sense. So there's like this thing called an LBD. It's a little black dress, and I think a lot of women are familiar with this concept, but I had no idea. And so if you search for LBD, they search for dresses that match this meaning.
Yes.
And similarly, you can say, okay, like winter coat. So it'll get a puffer jacket, even though it doesn't have like a winter coat.
Exactly.
Or neither of those words.
Exactly. And that's where it's magical when it works, right? But can you just remove the keyword search from the equation entirely? No. Because people definitely expect that the keyword's going to match. And a lot of times it does, right? Like if I had two paragraphs and one was about Shawshank and the other one was about Steve Jobs, right? I don't want to get those two mixed up, right? So the keyword is definitely still going to be an important part, even in the models, the embedding models.
Nice.
So what are some cool things that you've seen people built with LlamaIndex?
Oh, there's so many cool examples. I think some of the really, really interesting things that people are building are like non-chatbot applications. So just thinking about like, hey, can I have like a bunch of financial documents and can I make like a decision on those, right? Now, the models themselves, maybe they're not like, this generation ready to do that yet, but that's really interesting, right? Like doing like some kind of like, I'm going to ingest these documents and I'm going to make it like an automated decision on these models. I think the other things that like I've seen that are really interesting, like some of these things like you don't even think necessarily, they're not applications that necessarily you even think have LLMs at all, right? So for example, your example, that little black dress example, to a user, that's just search, right? Like they don't know that there's an LLM, but can the LLM make that happen? And especially with multimodal, make that even better? Absolutely, right? So like there's some of these applications where I think we're going to see a lot more of these applications where people aren't even aware that it's being processed through an LLM, but that's exactly what's happening.
That's true. So you know a lot about LlamaIndex and all of its capabilities, and you mentioned some of the stuff that you saw people building, like non-chatbot applications. What are some things that you think are possible to build that you haven't seen yet? Is there anything that like you think like, oh man, like we could really help with this use case that you just haven't seen a single person build? Or maybe is everybody using it to this full extent?
Saying that we haven't seen a single person build is a little bit hard.
Or maybe like not built as well as you think it could be.
Oh, there's so many things that are not built as well as they could be in the market right now, right? So why did I join LlamaIndex? Okay, I was working on chatbots at Apple for the last 7-8 years. Okay,
On Siri?
not Siri, not Siri. So it was a product called Apple Business Chat, and we had a product, and we actually have a chatbot on WeChat also. These are all public. And the chatbots we built, right, which are still live, right, and not just Apple's, right, like you can go to Best Buy or Comcast or any of these companies. If you compare that against what ChatGPT does, it's like you're like, which fifth grader built these, right? Like literally, it's like, it feels like so night and day now. Obviously we had a bunch of resources, a ton of user data, like, we had good people, right, working on this stuff, but it really, really is like night and day. And there's like so many of these applications, so many of these traditional like NLP applications. We were just, in multimodal even. I was just talking to somebody at the hackathon. It's like, if you think about image recognition, obviously a very established field. One of the issues with image recognition is that to train that image recognition model, you need lots of data. And let's say it's raining, okay? And you don't have any data or you have very little data where you have raindrops on your camera. Guess what? When you have that application out in the real world and it's raining and you get raindrops on your camera, that model is going to freak out. It does not know how to handle it.
Because it hasn't been trained on the raindrops.
It has not been trained with images with raindrops on them. But if you look at multimodal LLMs, they can handle it totally fine. It's not a problem for them. Right now, they're probably a couple generations behind the text. They're going to improve over time. But that's like amazing, right? It's a total paradigm shift between what we used to think was necessary, which is that you have to literally or a voice model, you have to literally capture people with every single possible accent, or the model's going to freak out. And with voice-based LLMs, that's not the case. So there's going to be so many of these applications that we haven't even thought of.
Yeah. So one thing I noticed is that LlamaIndex right now is at 0.9.43. What are you waiting for? Why isn't it 1.0 yet? What's the holdup? Is there like some sort of like feature you're trying to build? Any hard problems you're working on that you want to?
Well, so as an open source project, right? There's this tension. In terms of priorities for us, growing the community has to be the number one priority. There's so many people coming in, we see that at this hackathon. So many people who first time they've used LLMs, or, first time use LlamaIndex, or just they've used it like maybe once or twice, right? So first thing is you have to grow the community. And how do you grow the community? One of the most effective ways is you show people cool things. Like, people are very interested in seeing the future. But the thing about the future is that it's not necessarily ready yet, right? So priority number one is we have to grow the community. And to grow the community, we have to build stuff on the leading edge. Whether it's RAG, whether it's agents, we're building stuff on the leading edge, stuff that maybe not quite tested out yet. The second priority is to make things production ready. Why do we have to make things production ready? Because if we don't make things production ready, once people build their real applications, they're like, hey, I can't use this. So this year especially, we have a very, very big focus on making things production ready. But these two things are, as you can imagine, a little bit in tension, right? Because the more new cool things you build, the less production ready those things are going to be. So that's why we're not at 1.0 yet. We probably won't be at 1.0 for a bit. And if we are at 1.0, it probably won't be everything will be at 1.0. It'll be a subset, that's really production ready, that'll be 1.0.
Speaking of production ready, do you find that any of the people who are using LlamaIndex are using it in production at
Yes.
scale right now?
Yes. We know for a fact that there are a number of companies that are using LlamaIndex in production at scale. Now it's what parts of the library they're using, right? So they're using certain parts to do certain tasks. But yes, they are.
Okay, that's great. So we kind of mentioned being on the looking towards the future, building new things. What hard problems are you working on right now? Maybe like are you working on anything like related to like hardware limitations? You mentioned context window before, hallucinations. Any just type of hard problems that you're trying to solve that you think like in the future that you're gonna.
So we recently put out a bounty on Replit for what we call the kilodoc problem. Okay, you have 1,000 documents. How are you going to get good results out of that? Right, that's a hard problem that requires multiple layers of strategies. Most of the demos, people build 1, 2, 3, 4 documents. That's pretty much a solved problem at this point. But if you have thousands of documents, some of them may not be. You might not want to search over all of them. In fact, you don't want to search over all of them at the same time. So figuring out which documents you want to search over, figuring out how do you handle data that's incorrect, right? So this is something we talk about a lot, is like recency filtering. Any company, you go on the SharePoint, you go on the Notion, there's stuff that's wildly out of date and incorrect. Nobody bothers to go and clean that up, right? So how do you deal with that? So these are like sort of real production problems that we are actively working on solving this year.
That's great. That's exciting. So that's, I think, pretty much all the main questions that I had. Shashank, do you have anything else you want to ask?
No, this was a fantastic chat. Maybe just to wrap things up, to understand a little bit more about you and what got you interested in the space. So you mentioned working at Apple on maybe like the traditional chatbots. I'm assuming you had like some decision trees. And so what was your journey before that? What got you interested in tech, and particularly like AI, generative AI and LLMs?
Yeah, so I've been working on AI applications for a while now, and not just chatbots, but prior to that, I was in finance working on ML trading. But I think it's very rare when you're in a career. There's a few points in your career where it's like, literally everything I've built is obsolete. Okay, it's only happened to me twice. Okay, literally, and I'll tell you about the other time. I was an intern at Palm. Have you heard of Palm? You guys are young.
Yeah.
Okay, you've heard of Palm? Okay. Yeah. They used to be just down the street over here. Okay. I was at Palm. I was an intern in 2006. Okay. And I was having team lunch. And I'm like, hey, there's this article on Bloomberg that says that Apple's going to come out with a smartphone. And they're like, oh, Apple's, every year there's a rumor that Apple's going to come out with a smartphone. Palm invented the smartphone. Palm invented the personal, Palm-based computing device. That's why it's called Palm. And they were one of those 3 companies that had the first commercial smartphones. And then when Apple came out with the smartphone, our stuff was obsolete. It was so obsolete that Verizon exercised a clause in their contract to return the smartphones to us.
Oh, wow.
Wow.
Right? And you think, so the Palm smartphones that we had that were for Verizon, they had Verizon right here on the back, okay? When the OS booted up, the first thing that showed up, Verizon, okay? Not only was the smartphones locked to Verizon, back then, the radio chips weren't powerful enough to handle that many bands. So even if you unlocked it, there was no radio. You couldn't actually tune to the bands for the other carriers. When Verizon returned hundreds of millions of dollars of smartphones to Palm, those hundreds of millions of dollars of smartphones became hundreds of millions of dollars worth of garbage. Right? But that's what happened. The market, like Verizon was very clear. They said, look, nobody's buying your phones. I'm sorry. Okay? Like, nobody wants those things anymore. So, when I saw what the GPT API could do last year, I'm like, yeah, like the stuff we were working on, it's obsolete. It wasn't because we didn't have smart people working on it. It wasn't because we were under-resourced. It wasn't because we didn't have enough data. It's just obsolete. And so, I think those are very rare moments in your career. And the last time that happened to me, I went into finance instead of, I was a mobile developer, right? Like before the iPhone came out. Like think about how many mobile developers there were before the iPhone came out. And I obviously did not take advantage of it at all. So this time I'm like, I have to jump on this.
Yeah. It reminds me, did you ever watch the BlackBerry movie? I think they had a very similar situation to what you mentioned, where they had to return all the phones. I don't think it was Verizon. I think it was like AT&T or something like that. But it's crazy how things just change.
Yeah, overnight.
Yeah.
That's all I have.
Yeah,
Thank
same.
you so much for coming on.
Yeah. Is there anything that you want to mention? The floor is yours. Anything you want to that we didn't talk about?
Last question for you two.
Yeah.
Okay, I ask this question a lot. So, and I find that the community is split. Very simple question. Do you think the next generations of LLMs, whether it's GPT-5, GPT-6, Anthropic's, Claude 3, 4, do you think they're going to be exponentially better than the ones we have today? Or do you think they're just going to be marginally better?
I was having a similar discussion with another member from our group, Lonnie, and he was talking about the Chinchilla scaling law. So it's like you get 10x more data, 10x more compute, and we're going to get like a doubling in performance.
Okay.
And that kind of makes sense. It seems like we're hitting diminishing returns for what we can.
You think we're hitting diminishing returns?
Out of the transformer models and the way they're being deployed today.
Okay.
And that seems to coincide with what Sam Altman and Ilya and like other heads of AI say, where they don't think the same strategy will take us from GPT-4 to 5.
There's a technical question about whether the models are going to be exactly the same, and I agree with you. The models aren't going to be exactly the same, but practically, is GPT-5 and 6 going to be exponentially better or just a little bit better?
So to clarify, I don't think the same strategies will take us from GPT-4 to AGI. They'll take us to an incrementally better model.
But you think the next models are going to be incrementally better? Just
incrementally better. Yeah.
Okay. What about you?
So I think it will probably be some exponent better, like somewhere between like 2 and 10 exponentially better. And same person that you mentioned, there's a guy named Lonnie in our group who's an incredibly smart guy.
He's the CTO at Analytica?
Yeah. And he showed a paper mentioning that, and I forget all the exact nuance, but essentially the idea is as a model gets better, it will get exponentially better at reasoning. So you can, I think there was like a paper written sometime last year. If I find it, I'll put it in the show notes, but I don't know if I'll be able to find it. And it said that kind of like as you're able to increase just like the number of parameters in a model, it will be able to get around 10 exponentials bigger, something like that, of reasoning. And it seems like with the scaling law that Shank you mentioned, when you are able to scale these models bigger, which is simply a function of just like throwing more compute at it. And I think that...
And data.
Yes, compute and data. And I think that these companies have the motivation right now to just throw as much money and data at this as possible. And I think that, I don't know, like I think, for example, like Facebook, they've spent like billions or tens of billions of dollars training these open source models. I think people are seeing that NVIDIA is like $1 trillion company overnight simply because of CUDA. And I think that the will and the money is there to make that happen. Therefore, I think that when somebody comes out with the next version of GPT, whether it's 4 to 5 or, some other new model that has like some minor things, I think it will be some order of magnitude better. It's hard to say exactly, but I think it'll be significantly better and not just incremental.
I'm glad you two disagree because this is like, I've asked this question at different forums, and it is roughly a 50-50 split. Even on Twitter, like I've asked this question in a Twitter poll, roughly a 50-50 split. I personally am on the exponentialist camp. I don't think people are raising, billions of dollars to build the next version of the model because they think it's going to get like 10% better performance. But it'll be interesting to see because whether it's going to continue to improve exponentially or just incrementally is going to be a really big driver in the next few years.
Yeah.
I think regardless of the answer, it feels kind of like a winner take all. If there's a model better than GPT-4, that'll be the best model.
Yeah.
Yeah, that's true. There is definitely some consolidation happening in the space, which is possible. And I think the more money you can throw at this, and as long as you can make it accessible, people are going to use it. Although, complete tangent, I'm curious to know about. I think there's like kind of two camps when you think about these scaling models. The one is using the best model you possibly can, and then throwing it off to like some server somewhere. Because I think like inference on GPT-5 will be near impossible without some technological improvements, like maybe some severe like quantization or something, whatever they use to figure this out. But I'm also wondering, like, maybe some people think like, okay, these models are good enough and you won't even need to be exponentially better, but maybe you'll be able to get the equivalent of GPT 3.5 running locally on your Raspberry Pi or something like that. And there might be some really interesting use cases with that. So I think we'll see it on both ends. We'll see like models running on low power getting better, maybe not exponentially so, but like, equivalent to what we have now. And then like on the high end, it will be unbelievable.
Yeah.
Way faster, better, cheaper, local, bigger and smaller.
That's right.
All of it.
Yeah, just better in every way.
Thanks again, Yi.
This was a lot of fun.
Yeah.
Thanks for having me.
Thanks so much. Appreciate it.
Thank you.